Okay, so we're going to go through the roof bevels and lengths. This is the formula sheet that I've provided you on the resource page. As you can see down on the left hand side here, these are the things that you need to work out, which I've called items. And on the right hand side down through here, we've got all the formulas for each item. So you can see here that the first item is convert pitch ratio, which is 1 meter rise for whatever meter run that you're given, and converting it to rise per meter of run. So the formula over here is 1 meter rise divided by pitch ratio. So one thing I want to talk about scientific calculators is they are a little different, or they all work a little bit differently. But the very first thing that you want to make sure your calculator is set to is degrees. So on your calculator there, you've got a button that will either say DRG on it or something else. It might have DEG with some other buttons. You want to make sure that the scientific calculator is set to degrees. If you don't set it to degrees, it may be set to radian or gradient. If it's set to either of those other two, then you're going to come up with different answers and incorrect answers. So you have to make sure that your calculator is, first of all, set to degrees. Each calculator works a little bit differently. On this one, you can see we've got the tan, cos, and sine button. But in addition to that, we've also got the tan -1, cos -1, and sine -1 button. So you would use these buttons wherever you've got pressed a shift or a second function button. So you can see over here in this second formula, it says second function tan. So in other words, before I hit the tan button, if I had a second function button somewhere here, I would press the second function button and then I would hit the tan button. This calculator here doesn't have that. So I would actually just hit the tan -1 button. On other calculators, the second function button is replaced by a shift button. So wherever you've got that sort of calculator, where it says second function, just press shift and then the tan or cos or sine, whatever is indicated in the formula. But if your calculator looks like this, wherever there's a second function in the formula, you would make sure that you press either one that has the -1 and not the others up here. So I've made sure that the calculator is set to degrees. I've cleared any content. I'll go ahead now and start with the first item that I need to calculate, and that is converting pitch ratio to rise per meter run. So the pitch ratio for this roof is 1 to 1.732. So that is 1 meter rise to 1.732 meters of run. So I need to convert that. So it is 1 meter rise divided by the pitch ratio. So it's simply just following the formula 1, which is 1, divided by, and the pitch ratio itself, which is 1.732. So 1.732. I hit the enter, and it gives me an answer of 0.577. Now that's rounding up to 3 decimal points. So any length you want to round up to 3 decimal points. Any angle or bevel you always want to round up to 1 decimal point. So this is a length. So I need 3 decimal points. So the answer would be 0.577. So that's converting the pitch ratio, which is 1.732, or a pitch ratio of 1 to 1.732, to a rise per meter run of 0.577 per meter run. So what I'll do is I'll put a sticky note on there to give me the answer, so I can refer back to it later. 0.577, and there's my answer there. You can see for the conversion of the pitch ratio to rise per meter run, it's 0.577. So I'll just clear that and go on to the next calculation. The next calculation is to convert rise per meter run to the pitch of the roof, or the roof angle in degrees. Now the pitch of the roof also happens to be the common rafter level bevel. So as soon as you work out the pitch of roof, you're also working out the common rafter level bevel. So I'll go ahead and we'll do this next calculation. which is converting rise per metre run to pitch of roof. And you see here that the formula is second function tan, and in brackets rise per metre run. Now, this particular calculator, I've actually got to do the tan afterwards, after I do this part of the calculation. On some calculators, you'll be able to put the formula in straight as you see it there. On others, you're going to have to probably do this part of the calculation first, then hit the tan or the second function tan. So again, you just need to be familiar with the way your calculator works. So I'll do this part of the calculation first, and it's in brackets, so I'll start with the brackets. And it's rise per metre run, which is this answer here, which is 0.577. So 0.577, and I'll close the bracket. And then I need to second function tan this. So I don't have the second function button, but I do have the tan minus 1, which is the same thing. So I'll hit tan minus 1, and it gives me an answer of 29.98 and so on. So this is actually the angle or the pitch of the roof. Now, as I said before, anything that determines a length, like this calculation here, you need 3 decimal points. But here, we're actually determining the pitch or the roof angle in degrees. So we only want 1 decimal point, so which would be 29.9, but the 8 here would round up the 9 to a 0, and then the 29 would become 30. So that would end up being rounded up to 30 degrees. So I'll just put that in a sticky note as an answer for there, and put in 30 for my answer for the conversion of the rise per metre run to pitch of roof. So there it is there, 30 degrees. I'll just clear that, and I'll move on to the next calculation. The next calculation is rise per metre run from pitch of roof. So let's say that you had the pitch of the roof, in this case was 30 degrees, you didn't have the pitch ratio, so you can determine the rise per metre run from the pitch of roof, and the formula is this, tan and pitch of roof. Okay, so you might be able to put that straight into your calculator as in tan and bracket 30, close bracket, and answer, and it'll give you the rise per metre run, which should still give you the same answer that we've got up here, which is 0.577. On this calculator, I'm going to have to do the pitch of roof first, then hit my tan button. So this is the calculation I'm going to do next. Rise per metre run from pitch of roof, and the formula is tan, and then the pitch of roof in brackets, and that will give me the rise per metre run. So on this one, I have to put the 30 degrees, which is the pitch of roof that we worked out earlier, or that we were given. And then I hit the tan button. It's just tan this time, it's not second function tan, just tan, and it gives me the answer of 0.577, as you can see before, which is the same as the rise per metre run, and it should be the same as well. So I'll put a sticky note on that as my answer, so 0.577, and that is again the rise per metre run. So the next thing we see on the items list is the plan length of hip per metre run. So what that means is that the plan length in plan view, or the length of the hip in plan view, for every 1 metre of run. We don't actually have to work that out, although I've already worked it out for you, because it's a handy number to remember that a standard hip is at 45 degrees to the wall plate. So what that means is that for every metre of run, the plan length of that hip will be 1.414. Okay, so you'll use this number in a few instances as we go further along, but just remember that the plan length of hip for a standard hip roof will be 1.414. That's pretty simple. So there is actually no calculation involved there for you. I've actually given that to you as a figure to remember, because you'll repeatedly use that. So I'll just go over here and just clear that and move on to the next calculation. And the next calculation is our bevels. And the next calculation, we start with our bevels. And it's bevel number 1, which is the common rafter plumb bevel. So the common rafter plumb bevel the formula is second function tan, and in brackets 1 metre divided by the rise per metre run. Okay, so again with this calculator I've actually got to do this part of the equation first, and then I'll do the second function tan part after. So yours, you may be able to put it in, like I said before, as you see it, straight into your calculator. Okay, so we need the 1 metre run, and we need the rise per metre run. And the rise per metre run we worked out earlier, which is the 0.577. So it's simply a case of going over to your calculator, and in brackets 1 divided by, I'm just following the formula, 1 divided by rise per metre run, and the rise per metre run is 0.577, so enter 0.577, close bracket. That gives me this answer, which isn't yet the angle because I have to complete my calculation and then hit second function tan, or if your calculator has a shift button, shift tan. Mine doesn't have either, but it has this tan -1, which is the same thing. So I hit that button there, tan -1, which is my second function tan button, and there's the angle there, and it's 60 degrees. Now you can see again, if I round that up to 1 decimal point, it would still stay at 60 degrees because the 1 won't round up anything. So it has to be 5 or greater to round up. So you can see in this case the 5 will round up the 1 to a 2, but the 2 is lower than 5, so it doesn't have any effect on the number before it. So the answer for this common rafter plumb bevel is 60 degrees. So I'll just put the sticky note in there because we'll refer back to it again some other time. So it's 60 degrees for that plumb bevel. I'll clear the calculator and we'll go on to the next calculation. So the next calculation is bevel number 2, and bevel number 2 is the common rafter level bevel, and the formula for that is second function tan, rise per metre run divided by 1. So you can see this part of the equation is essentially flipped from the previous, and that's correct. So it's rise per metre run, which is the 0.577 divided by 1. So, I mean, if you wanted to, you could just not do that part there because you know that anything divided by 1 is going to be whatever it is. So in this case, 0.577 divided by 1 is 0.577, and then you'll just have to second function tan that. I'll do the whole equation just so that I'm following this formula. So again, I need to do the brackets part first for this calculator because that's the way it works. So I start with the brackets and then rise per metre run, which is 0.577 divided by 1. I close the bracket, it gives me that answer, and then I have the second function tan, and my button for second function tan is the tan -1. I hit that, and there it is there, the 29.98, which is the same answer that we got before. But like I said before, with bevels and angles you need 1 decimal point. But in this case, the 8 would round up the 9 to a 0, and the 1 would go to the 29, add to the 29, which would make that 30 degrees. Okay, so for the common rafter level bevel, the answer would be 30 degrees. I'll just enter that there. So before I move on to the next calculation, I'll just clear the calculator. And I need to work out the true length of common rafter per metre run, which is the TLCR per metre run. I can't do the next bevel until I've worked this out. So I've set out this formula sheet in the way that, or the procedure that you would need to use. So I'll just highlight that there. That's the next one that we go on to. We can't do creeper edge bevel. We can't do the next bevel until we've actually worked out this. And the formula is 1 divided by cos and then common rafter level bevel, which you worked out previously, which is 30 degrees. So input that into my calculator. It's 1 divided by bracket, because that's the way this calculator works. I've got to do the brackets part first, and 30, which is my common rafter level bevel, close bracket, and then I'll hit the cos button. Okay, so that gives me the answer for the cos 30, and then I also need to hit the equals button because that is not the answer yet. I need to make sure I hit equals, and it gives me an answer of 1.1547. Okay, so The answer will be with 3 decimal points. So the 4, because of the 7, the 4 will round up to a 5. So the answer will be 1.155. Okay, so I just take a sticky note and I'll put the answer there so I can refer back to it for the next calculation. And the answer will be 1.155, and that's in meters. 1.155. I'll just clear that. Okay, so the next calculation I'll do is for bevel number 3, which is the creeper edge bevel. Okay, so the formula for that is second function tan, and in brackets 1 divided by the TLCR per meter run, which I worked out just a minute ago. It's 1.155. So again, for this calculator I need to do the brackets first. Yours may be a little bit different, but it's 1 divided by TLCR per meter run, which is 1.155. Close bracket, and I've got to go second function tan, so which is the tan minus 1, and that gives me an answer of 40.88. So the second 8 would round up the previous 8 to 9. So the answer, because this is an angle or a bevel, we need 1 decimal point, so the answer would be 40.9 degrees. So I'll just post that there with a sticky note. So we can refer back to it later. There it is there. Okay, so I'll clear that and we'll move on to the next calculation. And the next calculation is bevel number 4, which is for the purlin edge bevel. So the formula for that is second function tan, and it is TLCR per meter run divided by 1. Okay, so again, this formula is this part of the formula is similar to the previous. They're just flipped. Okay, so and there's a reason for that, because the angles, these two angles or bevels, are found in the same triangle, the same as bevel number 1 and number 2, also found in the same triangle. Okay, so the formula for bevel number 4 is second function tan, and in brackets TLCR per meter run, which we worked out previously, which was 1.155 divided by 1. So I'll input that. So for this calculator I need to start with the brackets, and it's TLCR per meter run, which is 1.155, and divided by 1, close bracket, and it's second function tan, so tan minus 1, and it gives me an answer of 49.1 degrees if I'm going to use 1 decimal point. So I'll post that there, 49.1, and that's the bevel angle for the underpurlin edge bevel. So as you can see, 49.1 and 40.9, if you add those together, equal 90 degrees. And the reason is because these two bevels, 3 and 4, are in the same triangle. So if you have 180 degrees in a triangle, and if you deduct the right angle of that triangle, then that will leave you with 90. So these two must end up equaling 90. If they don't, then there's an error in your calculation. Now the same can be said for the common rafter plumb bevel and the common rafter level bevel, because they're found in the same triangle as well, and so they must equal 90, and they do. As you can see, the common rafter plumb bevel is 60 and the common rafter level bevel is 30. Those two added together equals 90. So if they don't equal 90, then again you've made a mistake in your calculation. You need to check that. Now that will be the same also for the hip plumb bevel and the hip level bevel. So if those two are added together, they will equal 90 as well. And that's about the limit. So for the rest of the bevels, they're not found in the same triangle. Bevel number 1 and 2 are found in the same triangle. Bevel number 3 and 4 are found in the same triangle together, and bevel number 5 and 6 are found also in the same triangle together. So these three sets here come in pairs, so they have to equal 90. So I'll go on to the next calculation, and the next calculation is bevel number 5, which is the hip plumb bevel. And the formula for that is second function tan, and then we've got bracket 1.414, which is the plan length of the hip per metre run. There it is there, 1.414 divided by the rise per metre run, which is 0.577. So again, I'll do for this calculation. So again, for this calculator, I need to do the brackets part first. So I'll just clear my previous calculation and then start with brackets 1.414 divided by rise per metre run, and in this case our rise per metre run was 0.577, and I'll close the bracket. That gives me that answer. It's not yet complete, so I then need to second function tan that, which is this button here, and that gives me 67.8. Okay, so for the hip plumb bevel, the answer is 67.8 degrees. So I'll just post that. And there it is there, 67.8 degrees. Okay, so for the next bevel, bevel number 6, is the hip level bevel. And the formula for the hip level bevel is second function tan, and it's rise per metre run divided by the 1.414. So rise per metre run again is 0.577 divided by 1.414. So we start with the brackets, 0.577 divided by 1.414. Close the bracket, and I must second function tan that. So there it is there, tan minus 1. And it gives me the answer of 22.19, so the 9 will round up the 1 to a 2, so it's 22.2 degrees for the hip level bevel. So I'll just post that on the sticky note as my answer, so 22.2 for the hip level bevel. Now, before we work out bevel number 7, we need to work out the true length of hip per metre run, which is the TLH per metre run. And to do that, it is 1.414 divided by the cos hip level bevel, which we just worked out, which is 22.2. So we need to just enter that into the calculator. I'll just clear this calculator first. And 1.414 divided by cos hip level bevel. So it's 1.414 divided by hip level bevel, because the way this calculator works, I need to put the hip level bevel in first. So it is 22.2, and it is cos only, so it's not second function cos. And I also need to hit the equals button to get the final answer. And the final answer is 1.527. So I'll just post that. Using 3 decimal points, the answer for the true length of hip per metre run is 1.527. And there it is there. So we just did this calculation. We're going to do the hip edge bevel now, bevel number 7. So bevel number 7 is the hip edge bevel, and to determine that we need to use second function tan, and in brackets 1.414 divided by the true length of hip per metre run, which is what we just worked out. So I'll do the brackets part first, because that's the way this calculator works. So I'll just clear that calculator and then do the calculations. So I'll start with the brackets, and it's 1.414 divided by the true length of hip per metre run, and the answer for that was 1.527. Close bracket, and it is second function tan, so I've got to use the tan minus 1, and it gives me an angle of 42 0.79, so that would end up being 42.8 degrees. So I'll just sticky note that, 42.8 degrees. And that is the hip edge bevel angle, 42.8 degrees. We can move on to the next bevel now, which is bevel number 8, and that's the Underperface bevel. And the formula for that is second function tan, and in brackets, true length of common rafter per metre run divided by the rise per metre run. So we've got the rise per metre run up here, and we've got the true length of common rafter per metre run just there, which is 1.155. First of all, I'll just clear my previous calculation, and I'll do the brackets part first. So start with the brackets, and is TLCR per metre run, or true length of common rafter per metre run, and there it is. Here we go. There it is there, which is 1.155. 1.155 divided by my rise per metre run, and the rise per metre run we worked out, and it was 0.577. And I'll close the bracket, and I also need to second function tan that, so I'll hit the tan minus 1 button, and there's the answer there. It's 63.45. So this 5 would round up the 4 to a 5, so the answer is 63.5 degrees. So I'll just post that with a sticky note for this bevel, which is 63.5 degrees. So the pearl and face bevel is 63.5 degrees, as you can see there. So I'll just clear that calculator. Now, the next part of the next item to work out is the backing angle line length per metre run, or the ball per metre run. And this is calculated by the rise per metre run times cos hip level bevel. And the level bevel is over here, which is 22.2 degrees. So if we can work that out, I'll do the calculation with rise per metre run first. The rise per metre run was 0.5, the rise per metre run was 0.577, so 0.577, and it is times or multiplied by the cos hip level bevel. So I'll do the brackets first, and the level bevel for the hip was 22.2 degrees. Close that, and I've got to use cos this time, so I'll hit the cos button, and then I'm going to hit the equals button to get the final answer. And the final answer for this is 0.534. So I'll just put that in a sticky note for that, 0.534. Okay, so I've just worked out the backing angle level line, and you need to work that out to determine what the backing angle for the hip is. So I'll just go and clear this calculator, and then we can move on to bevel number 9, which is the backing angle of the hip. So the formula for that is second function tan, in brackets 1.414 divided by BALL per metre run, which is what we just worked out a second ago. Okay, so we'll do the brackets part first, because that's the way that this calculator works. So it is brackets 1.414, and it's divided by, and the ball per metre run, which is 0.534, 0.534, as you can see there, and close bracket, and then I need to second function tan that, and the angle is 69.3 degrees. So again, I'll take a sticky note, and the backing angle for the hip is 69.3. So that's determined all the bevels for the roof, for a standard hip roof. And also, obviously, you'll be able to use some of these bevels just for a standard gable roof, for common rafter plumb bevel and common rafter level bevel, obviously, is all you'll need. But For a hip roof, you'll need all the remaining bevels. And you've also determined your rise per metre run, plan length of hip per metre run, and also your true length of common rafter per metre run and true length of hip per metre run, which you'll use these to determine the actual length of your hips and the actual length of your rafters and so on. So we'll refer back to those in the next video, which is determining all the lengths of the roof members. Okay, so now that we've run through that, what I recommend you do is go back through those calculations and practice them on your calculator, because as I said before, so every calculator works a little bit differently, so I suggest you go back and practice those calculations and get used to the way your calculator works and how you need to input that information into your calculator to come up with those answers. So have a go at those, and the next video we will move on to actually working out the lengths of roof members.